I want to talk about two of these questions today because you're going to see one similar to these tomorrow. But they're all very, very similar in the way you approach them. There are some things here I want to talk about that are just kind of mathematical concepts that I want to make sure that we all understand before we move on. It kind of governs the way that we deal with things, and the reason I ask you a lot of times is to leave answers in a certain format. So we'll see that here in a moment once we solve for x here. As we're looking at this, we're looking at the side, 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 and side, angle, side inequality theorems. Okay. Remember, side, 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 what that means is that I know two sides congruent to two sides, and then I know the third side to be different. Side, angle, side, again, I start off with two sides being congruent to two sides, but then I know the included angles are different. Okay, so we kind of want to look at what we have here. If I look at angle or segment 7 here, sure you guys agree it's congruent to that 7? Would this distance of 6 be the same as that distance there of 6? Okay, so you got the two sides that are necessary to be congruent in both those. Now we're going to try to decide, do I have angles that are going to allow me to make a comparison about sides, or sides that allow me to make a comparison about angles? Okay. 12 and 8. Are you able to look at 12 and 8 and give me an understanding if I were to just give you, let me, there we go. There we go. If I were just to give you 12 and 8, can you make a comparison about which one's bigger? Yeah. If I were to give you these two things, and not knowing what x is, can you tell me which one's bigger there? No. Okay? So the argument that I'm trying to make here with you is that you know something about the third sides. You have information about SSS here. Okay? Because you can tell me 12 is bigger than 8. Okay? Well, if 12 is bigger than 8, then let's go opposite 12. Opposite 12 is going to be that angle right there, right? So it'd be 140. Opposite 8 is going to be that angle right there. 7x plus 4, correct? Yep. The way that the sides are different is the exact same way that the angles opposite are different. So if 12 is bigger than 8, 140 is bigger than 7x minus 4, or 7x plus 4. Does that make sense? Okay. And now all we've got to do is solve that equation, or inequality. 140 is greater than 7x plus 4. 136 is greater than 7x. 136 over 7 is greater than x. I think yesterday we talked about how we're allowed to use a symmetric property and flip these things. But remember, if all I'm doing is flipping them, then this inequality symbol needs to still be pointed towards the x, right? So I need that. So I'm going to write it as x being less than 136 over 7. Is that okay? Yep. I'm going to leave it that way. I'm going to come back and talk about that here in a moment. Now, if I choose numbers that are less than 136 over 7, there are some numbers like negative 10. That would be a problem here. I'd give me a negative angle measurement, right? If x is 10, negative 10. So what we always want to do is we want to go back through our picture and pick out the expressions that represent angles and distances. In this case, so we only have the angle, so we say 7x plus 4. And now we're going to write down or force that thing to be what kind of number? It always has to be positive. So in inequality terminology, to say that we have a number that's positive is that we're going to say it's greater than 0. Okay? That says whatever this angle is, greater than 0 means it's positive. So now can I subtract 4 from both sides and do that, right? Is that all right with everyone? Okay. When we do this, so both these properties need to be true at the same time. This needs to be greater than 0. It has to be a positive number, and this angle here has to be bigger than that angle. Does that make sense? Okay, so we need these two inequalities to be true at the same time. Now, algebraically, these are things that you talked about last year. The word and implies this symbol, which implies the word intersection, which some people like the word overlap. Okay? But ultimately, when I see that word and, I need the intersection of these two inequalities. So the way that you're going to find your final answer and write your final answer, if you're writing on paper, and this is kind of the, I think, the downfall to using things like Math Excel or these online programs, and it happens with the end of course exam. So your argument might be, well, why even use them? Well, because we're tested with them, so that's why we use them. If you were writing by hand and you wrote that as your answer, I'm fine with that, because that's exactly what you need. Okay, but when we have an and statement, an intersection statement, sometimes called a between statement, a lot of times we like to present our answers using a different format or different notation. So this is how we do that. We're going to graph both these inequalities. So I'm going to graph x is greater than -4/7, so maybe -4/7 is there. Greater than that, we talked yesterday, you talked last year, that would be that graph, right? Does that make sense? We're shading all the values that are going to satisfy that condition, meaning anything I pick off that blue ray, when I plug into here, it's a true statement. 0 is over here, right? When I plug 0 in right here, is 0 greater than -4/7? Yeah, so everything over here is going to do something like that. I'm going to find 136/7. Maybe it's right there. We know it's to the right of -4/7. And now if I want to be x is less than that, we'd be shading that direction. Okay? Now, the word and means a value that you choose has to be on the blue and on the red. Does that make sense? Well, the only places that's on the blue and on the red would be right there, correct? Okay? And those values then are -4/7 is less than x is less than 136/7. That's how we would write it a lot of times, the way it's prompted in like Math Excel or the end of course exam. When I have that red rectangle around, says the exact same thing that I've got that black bubble around. Okay? They are both appropriate, both correct, but you got to pay attention to how are they asking me, how are they forcing me to write my answers, right? Okay? And it's the same thing as if they, if I find an answer to be 1/2 and they say type it in as a decimal, but I type in 1/2, I'm wrong, right? Okay, that's going to happen on the end of course exam. They're going to tell you to use particular fractions, maybe type it in as a ratio. They might say round to the nearest tenths, whatever. If it's 2/5 and they want as a decimal, but you type in 2/5, you're wrong, even though it's equivalent to the 0.4 that they're looking for. Okay, so you got to pay attention to directions like that, and this is just one of those things. All right, here's my question to you. A lot of times we want to, because this has been trained inside us since 4th, 5th grade, when we deal with fractions like that, don't we want to take the 4/7, put it as a decimal, and the 136/7, and put it as a decimal? We want to do that, right? Okay, I'm going to show you a picture here of this idea. So, and it doesn't matter how far out with the decimal that you go, you're going to arrive at the same type of argument that I'm going to make here. So this would be, let's just go 0.5714 is less than x is less than 19.4286. Do something like that. Actually, let's go 5.7. Okay. And you would see that this actually, right here, where it says 4-3, and that's actually a 4-2-8-5-7-1, 4-2-8-5-7-1, 4-2-8-5-7-1, and that repeats forever. Okay? Anything that repeats like that, we know should be able to be written as a rational value, right? A over B value. All right, so I'm going to do a little bit here with GeoGebra. It's going to take a little bit of time to write this out, so just give me a moment. Put it this way.
No, it's worse than before.
Okay, but like.
I was out of school for a week.
What is it?
It's basically like where you want really, it's basically like wow. No, it's not. No, it's not. This is very
All right, so what we've just done here, or what I've done, I'm going to give you just the x-axis, because that's all when we're using single variable inequalities, we just use a number line. So I'm going to get rid of the y-axis. And what I have in front here, if I were to connect the red points here, connecting the red points would give me that segment right there. So that is looking at the solutions just presented, okay? But the red one is how I type those in. That is using the rounded version. Does that make sense, everybody?
Yes.
Okay. The blue one, so we make the blue segment. That is using the exact version, okay? You see that when I make the red one is a shorter distance than the blue one, right? Meaning that these endpoints of the blue one are further to the right and left than the endpoints of the red one. Okay? Now, would you agree that at that kind of positioning, looking at them this way, that they look pretty much like the same segment, right?
Yes.
Okay? When I zoom in on this point, we zoom in far enough. Okay, so do we see that there's actually a gap between them?
Yeah.
Okay, so when I talk about the red segment, which is starting here or finishing here, okay, the red segment's going to go all the way back over to that point A on the other side, right? And the red segment was the rounded solutions. If I do that, do you visualize that these solutions right here are not incorporated?
Yes.
Does that make sense to everybody? So the blue solutions, the blue point is showing you kind of that upper boundary, or the upper limit of what my x value could be. Okay? The red one is showing that upper limit of what my x value could be once I round it. Well, how many solutions are in here if I round? How many solutions are in here that I kick out? A lot. What's another word for a lot? Infinite. We can continue to zoom in on that, right? And no matter what 2 points I look at, there's going to be an infinite number of values in between there. So when you round this negative 4/7 to that, and when you round this to that, or you round just one of those, even if you kept one of them as the fraction around and just the other one, regardless of how many times you round and how far you round, you eliminate an infinite number of potential solutions. Well, our goal here, guys, is to find all the solutions, right? So if I do that, I haven't found all the solutions. I've eliminated, I've kicked out some. Do we understand that concept? That's the math that I want you guys to understand, okay, when we work with these inequalities. Math Excel is kind of counterintuitive or counterproductive in regards to that, because they're going to ask you, type your answer in, round it to 2 decimal places. But when you do that, you really don't give me the right answer. Does that make sense?
Yeah.
Now, Math Excel, do they really care? Does Pearson really care about whether you're getting math or not, or understanding the math, the real math, and applying it correctly? Or do they care just that you provide them a subscription every year of $40? They want your subscription, right? Okay. So understand that the way that Math Excel works and the way that they ask questions isn't always aligned with the best way and aligned with the theory of the way we do our mathematics. Okay. Maybe it's aligned with that was the most effective way for them to code the question, or the most effective way for them to check a lot of different solutions. Does that make sense?
Yep.
Okay. So I understand that. I think a lot of people are thinking that Math Excel is the end-all, be-all. It's the holy grail of mathematics. It's not. Okay. It's a tool. Okay. But everything that happens within there, and we're thinking I'm getting 100s on every single assignment, and I know all mathematics. That's not true. Okay. It's only a tool that we're using to kind of help us get along that continuum of mathematics. Questions on that? Okay, so several things going on there. Hopefully we get the geometry, but also the kind of the number theory there of inequalities and why and you're going to hear me, and I'm going to urge you a lot to not round things. Okay, and even if you are told to round things, that's fine, but I want you to have the exact solution first. Okay? The exact solution was negative 4/7 less than x less than 136/7. That's the exact thing. Then when you round, understand what you're doing there and what that impact is of that rounding. So this is the last one I want to do.
I was looking at this. Are diamonds and rhombuses?
Diamond is really not much of a math word. Rhombus is the math word of what you think a rhombus to be or a diamond to be. Yes.
You want a diamond for Christmas? No, I want the rhombuses. I'll get you one.
When we say diamond, mathematically, are we talking two-dimensional? We're talking three-dimensional.
Yes.
But when I say rhombus, it's 100% two-dimensional. All right, so this one here, we have to use some of our previous knowledge to just get the ball rolling. Because I don't know any angles over in this triangle over here, right? Okay. I don't know any so our options are side, 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 angle, side, right? I don't know any congruencies that are going to allow me to essentially come down to a point where I can pick off a third side and say, I know, like in the last one, 12 was bigger than 8 or something like that. You don't know any of these numbers for these side lengths, right? So there's no way that I'm going to be able to talk about a side being bigger or smaller than another side based off numerical values. So side, side, side is not going to work here. Side, angle, side is actually the route we need to go. But in regard to using side, angle, side, I need to know an angle compared to an angle. I don't know any angles over here, right? Or do I? It's an equilateral. So here's the progression. It's equilateral. Equilateral is also equiangular. Equiangular means that all three angles are 60 degrees. So there's a lot of facts that allow you to kind of go through that linear progression from seeing that these three things are all congruent to allow you then to make the argument that all three of these angles are the same. That's a very small snapshot of what purpose is, or what the purpose that our theorems and corollaries and definitions serve for us in mathematics. Okay. So that being said, would you guys agree that that segment there is congruent to that segment there?
Yep.
So maybe that's that set of S's. Would you agree that this segment here is congruent to itself? So that is that set of S's. Would you then make the argument that this angle can compare to that angle?
Yes.
Are those the angles that are between the two S's? Yeah. So which one's bigger? 60 is bigger than 58, right? So once I'm able to make that argument about those numerical values, I can make the same exact argument about the sides that are opposite. So the side opposite 60 is x plus 2. That should be bigger than 2x minus 8. Is it okay? Subtract x from both sides, add 8 to both sides. Is it okay if I do all those steps at once? If you guys need me to slow things down and do this, just let me know. Now add 8 to both sides. Is that still x is less than 10?
Yes.
Okay, if 10 is greater than x, then that means x has to be less than 10. Okay, numbers that are less than 10, 0 is 1, right? If I plug 0 in, is that okay? If I plug 0 in there, is that okay? No. So 0 can't be an answer, right? 1. Is 1 okay? 1 will work here, right? Still fails there, right? So let's figure out the best way, instead of doing that trial and error, to do that. Now, you're telling me 4, right? Because with trial and error, maybe we can get a whole number. A lot of times the whole number doesn't show up, though. So the best thing to do, take all your inequalities. And we know that x plus 2 has to be bigger than 0. And 2x minus 8 has to be bigger than 0. Those two things have to happen at the exact same time, right? Meaning that both these distances, that distance there and that distance there, have to be positive numbers at the exact same time that I choose an x value, right? Solve both those. X is going to be bigger than negative 2. And so we get 2x is bigger than 8. X is going to be bigger than 4, right? X has to be bigger than negative 2, and x has to be bigger than 4. If it says and those things need to happen at the same time, which statement allows that to occur? X is greater than 4, okay? No matter what value you choose, let's just start with this one here. If I choose x bigger than 4, give me a number, bigger than 4.
That's not bigger than 4.
Okay, 4.1. If I plug 4.1 in right there, do I get a true statement right there? Yes. Do I get a true statement right there? Yes. So choosing 4.1 allowed both of those things to be true at the same time, right? Give me a number that's bigger than negative 2.
4.1.
Don't give me 4.1.
Negative 1.9.
Okay, let's just go 0. Let's try 0. It's just easier for substitution purposes. If I choose 0 and put 0 in right here, do I get a true statement? Is 0 bigger than negative 2? Yes. If I plug 0 in here, do I get a true statement? No. So do you see why? Because and they both have to be true, right? When I choose 0, they're not both true. That is an inequality that has to be met, but it's not part of our solution. This is the one that becomes part of our solution. That is called the most restrictive inequality, or a lot of times they call them conditions. And that's the one we choose when we have an and statement like this. We need both things to be satisfied at the same time. You choose the one that's most restrictive. If you understand what the word restrictive means, or restriction, Okay, what's restriction mean? Can't do it, right? Okay, you were limited, right? Mom says, I'm going to restrict you. You can't do these things. So you are limited in the things that you want to do and the things that you can do. Well, if I think about restrictions or restrictive conditions and inequalities, it's in regards to the amount of solutions that I have. If I compare x is greater than -2, being those solutions there, and x being greater than 4, those solutions there, if we draw the comparison that solutions are things that we can do, doesn't it look like this is most restrictive? Because there's less things that we can do there than there is here. Does that make sense? Okay, so that's why this is called the most restrictive. X being greater than -2 would be the least restrictive. Okay, you always choose the most restrictive when we're talking about an and statement. If that's the math that I'm interested in you guys understanding, okay, or trying to develop a comfort level with. If you don't get that right now, you can understand, or you can get your solutions by this procedure. You can say that x had to be bigger than -2. You can graph that. You can say x had to be bigger than 4. You can graph that. And you said earlier that x had to be less than 10, right? You can graph that. Okay? We wanted between these three inequalities, we wanted x less than 10 and x being greater than -2 and x being greater than 4. Well, the and means picture-wise overlap, right?
Yeah.
Or intersection. So we should be able to, the cursor, there we go. We should be able to see where they overlap right here. All three rays or sets of solutions are overlapping between 4 and 10, right?
Yeah.
Okay. So a lot of people ask me, well, why did you even do the -2? Because I didn't know at the beginning whether that was the one that I need to kick out of my solutions or not. Okay. If I go through the overlap and see where all three are overlapping, we see a -2 is not a component to the solutions, right? Is everybody okay with that idea? Now, just trying to get you on page with the way I think about this stuff. I think anybody can go through the procedures and understand, okay, Mr. Fay said take and use the inequality theorems to set up an equation that was 2x minus 8 is less than x plus 2 and solve that. And then he said take x plus 2 and set that greater than 0. Take 2x minus 8, set that greater than 0. Solve those. Put all three of those on the graph. And then my solutions where they overlap. My hopes are that you understand why those solutions are the solutions. Why we chose the overlap. Okay? That's the math part of things. Okay? I think a lot of people start to think math is just being able to do the calculations, right, Johnny? But we want, that's the conversation you guys were having at the beginning with science, correct? Okay? We want to be able to understand why we are doing those things, why we're doing those procedures, and how they work, and why they work. Because in the next one, when it changes a little bit, okay, and maybe all three of them don't overlap or something like that, how do I adjust and write my answers in regards to that? If I know why and how my answers are being generated and what they mean to me, it's easy to adjust to different styles of questions. Okay, it's easier than to take my algebra skills and lay them over into another course and apply them in another course, if we understand why. Is that all right? All right, so that's all I've got for you in regards to 5.7. I do want you guys to maybe write this down. Hopefully you've already got it somewhere. But that information right there is going to be pivotal for you tomorrow. If you go back to the vocabulary quiz I gave you on Friday, well, we didn't do too hot on that, okay? Which is disconcerting because we'd spent a week and a half talking about those objects, okay? And kind of for the most part, we only knew about half of them, even though we talked about them for a week and a half. If you're not understanding the terminology and you can't follow along the conversation, then there's no way that you're going to be able to do the work, right? Okay, I told last class if you were to get into, I know some of you know Spanish, but let's say that we don't know Spanish all that well. Would you feel comfortable going down to Mexico and start driving down there and trying to get somewhere without GPS or anything like that? Okay, you wouldn't because you can't read the road signs, right? Okay, so you're going to get lost traveling around somewhere where you can't read the road signs. Well, when you're in math and you can't read the road signs, you don't know what the vocabulary is, you're going to get lost. You're not going to be able to navigate and find your way through it. Okay? So please, 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 please heed my warning and learn your vocabulary. Okay? Somebody last class argued, well, I didn't know my vocabulary in algebra. You don't. A lot of times you don't. Because when you see an equation, there's kind of implied procedures in that equation. You kind of understand what you need to do. Because you've seen that before, you've done that before, you've practiced that kind of procedure over and over and over again. In geometry, you can't do that. Not every single question is the same as the last. Your vocabulary is what's going to allow you to drive through the system and be able to function within the system. Just learn your vocabulary. The rest of this course, I think you see it the most right now in this chapter, but the rest of this course is going to be very, 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 very difficult if we don't change our ways in regards to understanding vocab. Okay? I think you saw on that quiz the other day, I gave you, may have deleted it. Let's see if I can go back. It's not in that one. All right, I gave you a picture like this in I don't know why this thing is there. I can't get rid of it though. I gave you a picture like this and there are 2 or 3 of them, and I asked you what kind of point is I. Okay. Well, the procedure you guys need to go through in doing that is figure out, okay, those 2 segments are segments of triangles, right? Those 2 segments that are making I. They are that segment there, so let's just color it purple, and that segment there, color it purple. Okay? Now, in order to identify what kind of point I is, I need to know what those purple segments are, right? Does this black line matter at all in this process of finding I? No. Okay? So I'm going to somehow, whether I redraw or whatever, I'm going to try to eliminate it. This blue one doesn't matter. I try to eliminate. Now, that purple one, how is it created? What is point B? What do you call that for this picture? A vertex. What is point G? Midpoint. What segment starts with a vertex goes to a midpoint by definition? It's a median. You have a median right here. What's this one? A median. Medians come together at the centroid. Do you see how that's a game of knowing a bunch of vocabulary? If I don't know any one of those vocabulary words, I'm not going to be able to address that answer correctly. Okay? Going back a little bit, what was that? What's that blue line there? Based off the notation.
That's a circumstance. No, that's a purple.
Okay, what kind of line is it? It's a perpendicular bisector. That line has got a right angle right there, right? So it's perpendicular. These 2 marks there and these 2 marks right there tell us that G is a midpoint. So blue is a perpendicular bisector. Okay? What about that black one? What's that? Angle bisector. What? Now I don't have 2 perpendicular bisectors, but on that blue line is what point somewhere? Circumcenter is somewhere on that blue line. What is somewhere on this black line? End center. And we would need another one of those either blue lines or one of those black lines to find exactly the location of those things, right? Okay. I think you guys are kind of picking up, at least this class is picking up the need for understanding our vocabulary. Continue to do that. All right, continue to work with it so we can have those conversations and lectures and discussions are meaningful if you understand you can follow them all the way through.